Welcome to our channel. Today we're diving into the fascinating world of food science. Get your aprons and your safety goggles ready, because we're about to explore the delicious chemistry happening in your very own kitchen. Ever wondered how your favorite dishes get their incredible flavors? It's not magic, it's science. From the sizzle of a perfectly seared steak to the tangy delight of sourdough bread, we're uncovering the amazing reactions that make our taste buds sing. Get ready to unlock culinary secrets and become a true kitchen scientist. Let's get cooking! Have you ever wondered why seared steak has that irresistible crust and savory depth of flavor? The answer lies in a fascinating chemical transformation called the Maillard reaction.
When we heat our steak to a high temperature, amino acids and sugars on the surface of the meat react, creating hundreds of new flavor compounds. But that's not all. This reaction also creates that beautiful brown crust, adding a delightful texture to our steak.
The Maillard reaction is a complex dance of molecules, and understanding it allows us to control and enhance the flavor of our food. So, next time you're searing a steak, remember the incredible science at play. Caramel, that rich golden brown liquid with its alluring aroma and complex sweetness. But did you know that this culinary delight is a result of a simple yet mesmerizing chemical process called caramelization?
It all starts with sugar. When we heat sugar, its molecules break down and rearrange, creating a cascade of new compounds. This process not only produces the characteristic caramel color, but also develops a symphony of flavors, from buttery and nutty notes to hints of toffee and even a touch of bitterness.
Caramelization is a delicate dance of heat and time, and mastering it unlocks a world of culinary possibilities. Sourdough bread, with its tangy flavor and airy texture, has been a staple for centuries. But did you know that this bread comes alive with the help of tiny microorganisms?
Sourdough relies on a starter, a mixture of flour and water teeming with wild yeasts and bacteria. These microscopic helpers ferment the dough, producing lactic acid, which gives sourdough its signature tang. This fermentation process also creates carbon dioxide bubbles, giving the bread its airy texture.
Baking with sourdough is like nurturing a living ecosystem in your kitchen, a testament to the wonders of natural fermentation.
Mayonnaise, that creamy, tangy condiment, might seem like a simple mixture of oil, egg yolks, and vinegar.
But its smooth, stable texture is a triumph of a fascinating scientific phenomenon: emulsification. Oil and water, as we know, don't naturally mix.
That's where egg yolks come in, acting as emulsifiers. Egg yolks contain lecithin, a molecule with a love for both oil and water.
Lecithin surrounds tiny droplets of oil, preventing them from clumping together and keeping the mayonnaise from separating. This emulsification process is the key to mayonnaise's delightful texture and its ability to elevate sandwiches and salads alike.
Pasta, a staple in cuisines around the world, undergoes a remarkable transformation when cooked. This transformation is all thanks to a process called gelatinization.
Pasta is primarily made from starch. When we cook pasta, the starch granules absorb water and swell.
This swelling causes the starch molecules to unravel and form a gel-like network, giving the pasta its soft and pliable texture.
Understanding gelatinization allows us to cook pasta perfectly, al dente, with just the right amount of bite.
Pickling, a time-honored method of preserving vegetables, is a fascinating example of food preservation through chemistry.
The process relies on creating an acidic environment that inhibits the growth of spoilage-causing bacteria. Vinegar, a common pickling agent, provides the necessary acidity.
The acid not only preserves the vegetables but also imparts that characteristic tangy flavor.
Pickling is a delicious way to extend the life of fresh produce while enjoying the vibrant flavors of fermentation.
We all love guacamole, that vibrant green dip made with avocados. But have you ever noticed how quickly it can turn brown?
This browning is due to a chemical reaction called enzymatic browning. Avocados contain an enzyme called polyphenol oxidase, which reacts with oxygen in the air. This reaction produces brown pigments, causing the guacamole to lose its vibrant green color.
But fear not, there are ways to slow down this enzymatic browning. Adding lime juice, which is acidic, helps to inhibit the enzyme and keep our guacamole looking fresh and green.
Beer, one of the world's oldest and most beloved beverages, owes its existence to tiny single-celled organisms, yeast.
Brewing beer is all about fermentation, a process where yeast consumes sugars and produces alcohol and carbon dioxide.
Different strains of yeast produce different flavors and aromas, contributing to the vast variety of beers available.
The next time you enjoy a cold one, remember the remarkable science of fermentation and the tiny yeast cells that make it all possible.
The poached egg, with its velvety smooth egg white and runny yolk, might seem like a culinary challenge.
But understanding the science behind it can help us achieve poaching perfection.
When we gently lower an egg into simmering water, the heat causes the proteins in the egg white to coagulate or solidify.
The key is to create a gentle whirlpool in the water, which helps to wrap the egg white evenly around the yolk.
Timing is crucial. Too short and the white will be runny, too long and the yolk will be overcooked.
Curry, a staple in many cuisines, is a celebration of flavor and aroma.
The key to a delicious curry lies in the art of spice blending.
Spices contain volatile compounds that evaporate when heated, releasing their characteristic aromas.
Different spices have different flavor profiles and react differently to heat.
Some release their flavors immediately, while others need time to develop.
Understanding these nuances allows us to create a symphony of flavors in our curries, balancing heat, sweetness, acidity, and earthiness. Thanks for watching. If you enjoyed this deep dive into food science, don't forget to like, subscribe, and hit the bell icon for more delicious content. Remember, the kitchen is a laboratory, and every dish is an experiment waiting to be explored. Let us know in the comments which dish you found the most fascinating. Keep experimenting, keep learning, and most importantly, keep enjoying the incredible science of cooking. Until next time, stay curious in the kitchen.